Yeah, please take the question.
Yes, sir.
The energy required to excite the hydrogen atom
The energy required to
excite the hydrogen atom from n is equal to 1
yes,
to
sir.
the second energy level. To the second energy level is
Yes, sir.
10.2 electron volts.
Yes, sir.
What is the wavelength of radiation emitted by the atom? What is the wavelength of radiation emitted by the atom when it get back to its ground state? When it get back to its ground state. We leave some space and take the next question.
Yes, sir.
The diameter of the innermost orbit. The diameter of the innermost orbit.
Of?
The diameter of the innermost orbit. Innermost orbit.
Yes, sir.
In the hydrogen atom. In the hydrogen atom.
Yes, sir.
Is 1.06. Is 1.06 angstrom units.
Yes.
What is the diameter of the 10th orbit of hydrogen atom? What is the diameter of the 10th orbit in the hydrogen atom?
Yes, sir.
Next.
Next question, sir.
Next question. Leave little space to work out.
Yes, sir.
I am hoping others to join meanwhile. Okay. So find the ratio of the longest to. I gave you the values, only how to express it in ratio. Find the ratio of the longest to the shortest wavelengths in. Find the ratio of the longest to the shortest wavelengths in the Lyman series of hydrogen atom. The Lyman series of the hydrogen atom.
Yes, sir.
One more.
Yes, sir.
The wavelength of second line of Bohr series. The wavelength of the second line of Bohr series. Second line of Bohr series is
second line of Bohr's
486.4 nanometers.
Bohr series is
4 nanometers.
486. 486.4
nanometers.
Yes, sir.
What is the wavelength of the first line of Lyman series? These models are simple and important from JE point of view.
What is the wavelength of?
First line of the Lyman series. First line of the Lyman series.
Yes, sir.
One more. How many wavelengths can be emitted? How many wavelengths can be emitted when hydrogen atom excited to n is equal to 4? Hydrogen atom excited to n is equal to 4 returns to the ground state. Hydrogen atom excited to n is equal to 4 returns to the ground state.
Yes, sir.
Also find the corresponding wavelength. Also find the corresponding wavelength and the least value of it. Also find the corresponding wavelength and the least value of it.
Yes, sir.
So, we'll now attempt the solutions. Pranav, late, huh?
Yes, sir.
You should be in time. I'm going to prepone the time. I told you already.
Yes, sir.
You should be ready. I got up at 4:30. Finished my Sanyha Vandanam and Navagraha Stuti, Aditya Hridayam, etc. and ready for the class. Being a lecturer. So being a student, you should be more fast, right?
Yes, sir.
Okay. The first one is, it is excited from N1 is equal to 1 to N2 is equal to 2. And then it is coming back to ground state. So you wanted the wavelength. We have the formula E is equal to hc by lambda. So lambda will be hc by E. Because it's hydrogen atom, if you want an angstrom units, 12,400 divided by 13.6 into 1 by n1 square minus 1 by n2 square. So many angstrom units is the answer. So this is n1 is 1, n2 is 2. So if you simplify, we'll be getting it as 1220 angstrom units. 1220 angstrom units. So it is 13.6 into 3 by 4. 12,400 into 4 by 13.6 into 3. So this is the simplification. Nearly it becomes 40. This will be around 300 and odd. So that's how you'll get 1220 angstrom units. You should be a little fast in simplifications also to fix in the time slot. That comes with practice and little logic. Normally in the exam, they don't trouble you for calculations. Second question. You're given the diameter of innermost orbital hydrogen atom. So, N1 is equal to 1. D1 is equal to 1.06 angstrom units. So you wanted the diameter of 10th orbit. D10 is how much? I gave you the formula for radius of orbit with the principal quantum number n as n square h square epsilon 0 by pi m e square. So from this, I gave you this relation also. Rn is directly proportional to n square because the diameter is equal to r by 2. We can also say this varies directly as dn. So I can write d10 by d1 will be equal to, it is n2 by n1 whole square. So it is 100. Therefore, d10 is 100 into 1.06. So it is 10.06 angstrom units. 10.6 angstrom units. Simple question. 10.6 angstrom units. Then question number 3. Finished, ma? Valli?
Yes, sir.
Okay. Find the ratio of the longest Lyman series to the shortest. In Lyman series. So longest corresponds to Lyman series means 2 to 1. Shortest corresponds to lambda to 1. So this is lambda varies nu bar is equal to 1 by lambda is equal to r into 1 by n1 square minus 1 by n2 square. So already I gave you this formula. So lambda varies inversely as 1 by n1 square minus 1 by n2 square. So for shortest, it is 1 by 1 square minus 1 by infinity by 1 minus 1 by 4. So I think I remember I told you. So lambda longest to lambda shortest in Lyman series will be 4:3. 4:3. Yeah, shall I clear the board? Shall I clear it, ma?
Yes, sir.
Okay. Fourth question. The wavelength of second line of Bohr series is given as 486.4 nanometers. And you're asked to find the wavelength of first line of Lyman series. Second line of Bohr series means first line is 322, second line is 422. First line of Lyman series 221. So lambda 1L by lambda 2B. What I mean is the wavelength of first line in Lyman series by the wavelength of second line in Bohr series. So it should be 1 by 2 square minus 1 by 4 square by 1 minus 1 by 4. So I get, this is, yeah, 1 by 4. We calculate all these values. Minus 1 by 16 by 3 by 4. So lambda 1L is equal to lambda 2B 486.4, and this is how much? 16 is LCM, 3 by 16. Please check. By 3 by 4. So this 3 is cancelled. This 4 is cancelled with the 16. So you are left with 486.4 by 4. So 1216 nanometers. That's all. 121.6 nanometers. Understood?
Yes, sir.
Okay. Pranav, completed?
Yes, sir.
Okay. Yeah, question number 5. There is a formula. The number of spectral lines when the transition occurred from a principal quantum orbit with the principal quantum number n is given by capital N is equal to n into n minus 1 by 2. You can please add it, n into n minus 1 by 2. So the number, please write number of spectral lines produced, number of spectral lines produced when electron in the atom jumps from nth excited state, I mean nth orbit, nth excited state to the ground state. To the ground state is given by the formula capital N is equal to small n into n minus 1 by 2. Very important. Small n into n minus 1 by 2. So small n here is 4. 4 minus 1 is 3 by 2. So 6 spectral lines are produced. And you also wanted the corresponding wavelength and the least wavelength. So the corresponding wavelength lambda is 1000 by 1 by n1 square. So it is 4 to 1. So 1 by n1 square is 1 minus 1 by 4 square 16. So it is 16 into 1000 by 16 minus 1 15. So this is 15600 sorry 15690 again 100, so 66.6. So 16 into 66.6 means 16 6 are 96, 16 6 are 96 plus 9 105, and 16 6 are 96 plus 10 106. So it is 1065.6 angstrom units. Sometimes they may ask you even the region. This will be less than 3800 angstrom units. So it is in yes, UV region. Less than 1 angstrom units gamma rays, 1 angstrom unit to 100 angstrom units X-rays, 100 angstrom units to 3800 angstrom units UV rays. Therefore, this particular line will be in the UV region, and he wanted the shortest. Shortest means maximum energy. So this itself is the shortest. This is shortest. Suppose if you want longest, longest will be there between neighboring orbits because it is jumping from fourth orbit. So it should be 4 to 3. Means we get lambda is equal to, it is 1000 by 1 by 9 minus 1 by 16. This comes out as shortest. So please simplify it. Sorry, this is longest, na? 4 to 3. Neighboring orbits, lesser energy, more longer wavelength. Longest. Earlier one, more energy, shortest wavelength. Shall we go to next? Next question. The total energy of electron in the first excited state of hydrogen atom. The total energy of electron in the first excited state of hydrogen atom is 3-3.4 electron volts. Minus 3.4 electron volts. First excited state corresponds to n is equal to, correct? Ground state n is equal to 1. First excited state means n is equal to, right?
Yes, sir.
What are the kinetic and potential energies of electron in this state? What are the kinetic and potential energy of electron in this state? So we have the formula for energy of electron in the orbit with the principal quantum number n as the sum of potential and kinetic energies. Potential energy I wrote, recollect the derivation what we did. So even the derivation what we did also can be framed in the form of questions. Very good model, very simple. Minus ZE square, only logic. Minus ZE square by 4 pi epsilon 0 R is the potential energy, plus ZE square by 8 epsilon 0 square R will be the kinetic energy. So, and the total energy will be how much? ZE square by minus ZE square by 8 epsilon 0 R. So what can you write? K is equal to minus E. Am I right? Only logic, no complication. K is equal to minus E. Correct? Huh? Any difficulty, please tell me. I'll explain. This is the expression for total energy. This is the expression for kinetic energy. So K is plus ZE square by 8 pi epsilon 0 R. Total energy is minus ZE square by 8 pi epsilon 0 R. So comparing these two, I get K is equal to minus E. Next, we can also write K is equal to minus U by 2. How do I get it? Comparing these two equations. U is minus ZE square by 4 pi epsilon 0 R. K is ZE square by 8 pi epsilon 0 R. So it is, if you put minus U by 2, you will get this expression. I just, otherwise you take the ratio, you will get the answer. That's a long process. This is a logical way of getting the relation. So what can I write? K is equal to minus E, K is equal to minus U by 2 means U is equal to minus 2K. And E is also equal to minus 2K. Correct? Huh? Sorry. E is equal to minus K. E is equal to minus K. U is equal to minus 2K. So substitute in this, already you have the value of energy. En will be equal to, yes, it is minus 2K plus K. Therefore, K is equal to minus En. So, minus of minus 3.4. So, kinetic energy of electron in this orbit is 3.4 electron volts. And the potential energy is minus 2K. So, minus 6.8 electron volts. Simple. So on reading the problem, you should put this step. Imagine the speed you need to acquire. After reading the problem, this step should come. Then you are on the track. So give some values. I have given you restrict and holidays diagram. I have shown you. I'll be sharing them today in my YouTube channel. Please subscribe it because different things will be coming into that. If you want to download or something, if you subscribe, you can have a complete access to my channel. So subscribe to that. I think I shared the link yesterday. Have you seen that link? Valli? Srivalli? I think Srivalli got disconnected. Pranav?
Yes,
Pranav?
sir.
Have you seen that link, Ray?
Yes, sir.
Yeah, Swarna.
Already have, sir.
Okay. Why, ma, you did not get the information? I sent
No, sir.
group, na?
Sir, I am not in the group, sir.
I think father's number is there. He did not inform you.
Okay, sir.
Father number is there. Okay. Fine. I think
Yes, sir.
only lost the connection. Yeah, she is perfectly coming at time. 6 o'clock sharp. She is there. Huh? Okay. I'll just communicate to her 1 minute. Have you understood this problem? Swarna and Pranav?
Yes, sir.
Yes, sir.
Okay. So as usual, after 10 minutes, again, we'll log in back, right? Take the next question. In question number 7 or 8 or 7. The frequency of first line in Lyman series in hydrogen spectrum is nu. The frequency of first line in Lyman series in hydrogen atom is nu. What will be the frequency of the corresponding line? What will be the frequency of the corresponding line in the spectrum of doubly ionized lithium? Doubly ionized lithium. So already I gave you this. Nu is equal to C by lambda. This is C into nu bar. C into nu bar for other atoms, hydrogen-like atoms with atomic number Z is Rz square into 1 by N1 square minus 1 by N2 square. So this is the formula. Means we have to write the ratio for it. So I'll be getting it as N1 and N2 are same because it is given as first line. N1 here is 1, N2 here is 2. Even for this, N1 dash is 1, N2 dash is 2. So I'll write a general formula. Nu2 by nu1 will be C and R are constants. So it is Z2 square by 1 by N1 dash square minus 1 by N2 dash square by Z1 square into 1 by N1 square minus 1 by N2 square. Here, because first line is asked in both, this will be cancelled since N1 and N2 are same for both. But some cases, first line in hydrogen atom of Lyman series and second line of doubly ionized lithium atom in the same series, they may ask. Then the values change. Or one case they may ask Lyman series, other they may ask Bohr series. So here it will be cancelled. So directly I can write nu2 by nu1 is Z2 by Z1 whole square, since Lyman series first line for both. Hence this 1 by N1 dash square minus 1 by N2 dash square by 1 by N1 square minus 1 by N2 square will cancel. Otherwise, if it is said that first line of Lyman series in hydrogen atom to second line of Lyman series in lithium, or second line of Lyman series to third line in Bohr series, like that if he asks, all the parameters will be present. So nu2 will be equal to Z2 is 3, 3 square is 9 times nu1. This is the answer. Very important. Add this to your formulae list. This is what task to be done by every one of you. What all formulae we are getting while doing concepts, while doing derivations, while doing the problems. You must add it in your list of formulae. For every chapter, you must summarize all the formulae, what we did in the class, plus you must summarize NCERT textbook. And just before exam, if you revise it daily, whatever, after finishing the class, if you revise them, it helps you a lot. One more. If the orbital of electron of hydrogen atom, if the orbital of the electron of hydrogen atom while excited from ground state to higher energy state, while excited from ground state to excited state, has an initial speed of has an initial speed of v.
Sir, could you repeat from while excited?
Yeah, I'll continue. While excited state is to excited state, correct? Ground state to excited state, its orbital speed is v. Its orbital speed is v. What will be the radius of the new orbit? What will be the radius of the new orbit? So here, speed is reduced to half, correct? Yes or no? Speed is reduced to half. Means we have the formula V is equal to NH by 2 pi mr. So V1 by V2 is R2 by R1 into N1 by N2. Plus another relation to be used in this is R varies directly as N square. Therefore, R2 is equal to R1 into N2 by N1 whole square. Now, relate both and get the relation between V and R.